Okay, good morning. Ne poнимаю русский. So, I will speak in English. For those of you not using, I see the headphones going on. For those of you not using the headphones, you'll be hearing my voice, my usual voice in English. For those of you using the headphones, you'll be hearing another voice in Russian, but that is not mine. So it's unusual for me to be in a city for the first time, but I am here for the first time. It's a beautiful place. It's always been an interesting place for me to visit. I've read a lot of history, especially about the, I think what you would call the Great Patriotic War, a great deal of which happened here, and had a chance to see your museum on that, which I've been to a number of historical museums around the world, and it's probably one of the most impressive that I've seen. So if you haven't had a chance to see it, you should go visit it. So this morning, talk about test estimation here. So to me, this is very important. I know that it is popular now for some people, especially in agile projects, to say, don't estimate, just do it. Well, come on, right? We have to have a plan. I mean, you have a plan when you go grocery shopping, right? Don't you bring a list? Don't you have some idea how long it's going to take? When you get up in the morning, you estimate your day, right? To say that we don't need to estimate software engineering and software testing is just foolish, in my opinion. Of course we have to estimate. We have to try to think of how long things are going to take. So, a good estimate is one that allows us to see into the future. Yeah? If you get up in the morning and you plan your day, I'm going to be here between this time, and then here, and then here, and here. At the end of the day, if you have actually been at those places during those time periods, you had a good estimate, right? And if you get home 4 hours late, and 2 things that you planned to do didn't get done, guess what? Your estimate sucked. Okay? So, how do we avoid creating estimates that suck? All right, that's some ideas I want to pass on here. So, one of the things that's a little different about estimating software engineering projects from estimating your day is, unless you are a school teacher or a tour guide, you are probably estimating your day for yourself. Of course, on a project, you are estimating your day for a collection of people, right? So, we need to talk to other people. Another thing that we will need to do is look at past history. Yeah? Look at some metrics. And we will need to negotiate. We will need to get people's agreement that this is how long things should take, this is what we should do. So let's look at that. Let's start with expectations. This is not the technical part of estimation, but it is in fact one of the most important parts. Because if people's expectations are that you can do things which are impossible, you will fail. Right? Yeah. If people's expectations are that you will do something which is possible, but you think that they want you to do something else, you will fail. Right? So, clarify expectations from the start. So some of my clients are in safety critical types of products like medical devices, things that get implanted in your body. Do you care if that works? No? Well, I think so. If you had something in your chest, you'd probably want to make sure that it was thoroughly tested, right? So the expectation there should be test completely, right? So the test basis, whatever you were supposed to cover, your risks, your requirements, your support configurations, everything should be tested extensively. Yeah? Regardless of cost and regardless of schedule implications. Okay, so that's one expectation. If we all have that expectation, good. Now another possibility is you have plenty of money, but you have limits on your time. Delivery dates must be met. So then do as much testing as you can, spend money where needed, but you have to be done by a particular date. That will limit your testing. Now the world that most of you probably live in is this third one. Here's some time, it's limited. Here's some money, it's limited. Test as much as you can, right? Do what you can within the time available. And so some of you heard me give my talk on risk-based testing yesterday, which is all about doing the best you can in the time available. Okay? So any of those three expectations are fine as long as we all share them. The problem is when people say, find all the bugs in a fixed period of time with very little money. Okay, this is impossible. It's what I refer to as breaking the iron triangle. So if you think about the way a project works, usually the beginning of the project, we're talking about a sequential life cycle, this will happen at the beginning. In an agile project, this will happen at the beginning of each iteration. A set of features are defined. Now in a sequential project, you then have a schedule and a budget that are set, typically. Right? Now in an agile project, the schedule and the budget are already set, aren't they? You're going to be done every 2 weeks, 3 weeks, 4 weeks, what have you, here's how much money you've got. Now the thing that people don't understand is that if you constrain the features, the schedule, and the budget, you are going to get whatever level of quality your software engineering process is capable of delivering. That's it. That's what's going to come out of the end. Unfortunately, some people have this expectation that you have a magic wand, like this, and you can walk up to a computer and hit the computer with the magic wand, and all the bugs will fly out and die. Do any of you have this magic wand? If you do, see me afterwards. I've got the clients, you've got the wand, we will make a lot of money. Okay? There are a lot of people out there that want this and think it exists, but you don't have it, I bet. Nobody has it. And if someone thinks you have it, all the estimating skill in the world will do you no good because they think you will do the impossible. Okay? So first off, avoid bad expectations. Okay, so getting the expectations cleared up. If you're working on a sequential or waterfall style project, the typical way of approaching estimation is to start with a work breakdown structure, right? So are you familiar with this? Use a tool like, say, Microsoft Project, something like that. How many of you are still working on waterfall style projects? Okay. How many of you are working on agile projects? Okay, most of you, all right. So if you're still working on waterfall or some hybrid waterfall agile, you'll need to have a work breakdown structure, and you need to start with the highest levels of the testing effort and break it down to the constituent tasks. Okay? Not terribly different than what you're doing at the beginning of each iteration in an agile project where you're decomposing user stories into tasks. Okay? But here there's a whole lot more to be decomposed. Now it's important that you not leave anything out, anything important out of your schedule. Okay? So when you're creating your work breakdown structure, a good thing to do is start with test execution. You might say, that's backwards. Shouldn't I start at the beginning? Well, no. Start with test execution because if you know what you are supposed to test, then you can work backwards from that to how you're going to prepare for it. The risk if you start from the beginning is that you might very well fit what you plan to do within the available schedule. Okay? That's the negotiation part that can come later. First of all, figure out how long it's going to take you to do what you're supposed to do. And make sure to get these down to small-sized tasks. I see schedules sometimes that have like 2-week long, 3-week long tasks in them. No, that's not a task, that's an activity, right? If you don't decompose things down to 1 to 2 day long tasks, you are likely to be surprised. Now in Agile, what's going to happen here is instead of a work breakdown structure, we're going to have a defined testing strategy during the release planning that's going to talk about here's how we test in each iteration. Here's the process. Now the content cannot be defined in the test strategy because during release planning, we have an initial release backlog, but we do not have the content of each iteration, right? Because if you were doing it that way, you would not be doing Agile development, would you? You're trying to predefine everything in advance. So what we need to define is a process by which the testing will occur. So at the beginning of each iteration, you're going to select your user stories. And you, as a tester, need to be involved in the estimation process. How many story points should be assigned? Okay? And this should be based on the level of risk. The riskier a user story, the more story points you want to assign it. Okay? So, how many of you have heard this term, planning poker? Okay, some of you. Okay, so planning poker is basically a form of the Defect Oracle technique, which I'll talk about in just a minute. It's actually nothing new. It goes back to World War II, Great Patriotic War. And you should be involved in that. Now, again, some people say, why bother with estimation? Well, if you want to be able to predict what you're going to be able to produce in each iteration, you'll have to have a known velocity. And the testing has to be part of that, right? If the testing's not part of that, what's going to happen? Well, you might very well have things done at the end of an iteration, but they're not really done because they won't be thoroughly tested. So if you're not being included in this estimation process in an Agile team, make sure that you are. Now, planning poker, Defect Oracle, the idea here is that each person participates, does their estimate, how long it's going to take to do something. And the idea is that when you estimate, you don't just shout out your estimate. You write it down, or if you're using the deck of cards technique, you select a card that corresponds to your estimate, right? Now, the point of that is to avoid something called anchoring. Anchoring is what happens when somebody blurts something out and then everybody else reacts to that, okay? We want to have everybody's ideas gathered first, then we discuss them. And if there are discrepancies, we vote again, individual voting first and then discussion. And eventually you're either done or done in the sense that everybody agrees, or you use the average of the estimates. That's usually an indication of a potential problem though if you're doing that, because if people don't agree, there's probably some problems in what you're estimating. People might not agree what it is. Now, another important part of estimation is dependencies. Understand your dependencies, okay? It's easy, especially in testing, to get in situations where you have a dependency that you're either not aware of or you are aware of, but it's external dependency, and that gets broken and you can be stuck. I had a situation where I was managing a testing team of about 50 or so people, and we had a testing planned, system integration testing planned to start on a particular day. And we had, millions of dollars worth of hardware, and it was all set up and ready to go, except for this one cable, probably about a $100 cable. The network administrator assured me that the cable would be ready on time. And like a fool, I believed him. So Monday morning comes, I'm supposed to start my system integration test. I go and ask him, where's the cable? He says, I don't know. I say, but you are supposed to know, and you are supposed to know that the cable is here. You told me that the cable would be here. It's not. So, the entire week of testing had to be replanned while we waited for the cable to show up. So, know your dependencies and know who you are dependent on. Right? If you are dependent on an external party, know who that external party is. And don't make the mistake I did. Don't assume that they will come through. See, I should have asked him the week before, shouldn't I? Not the Monday when the testing was supposed to start, but the Monday before the testing was supposed to start. I should have gone and asked him, where's my cable? And he should have said, oh, it'll be here shortly, like this week. And then I would have said, good. But what he would have said is, I don't know. And then I would have said, when is it getting here? He would say, oh, Monday. And I would have said, I no longer believe you. And I would have created a backup plan, right? So, understand your dependencies. Understand what's called your critical path, okay? The critical path, sequences of activities and tasks that, such that if any one slips, it will delay later tasks, okay? And that we were on the critical path, unfortunately, with that cable. Okay, know who needs to do what. Know your people, know their skills. And remember during estimation that if you're asking somebody how long something's going to take, and they've never done it before, how good is their estimate? Is it a good estimate, you think? No, probably not, right? So, know your people, know their skills. Make sure that you've thought about your environments. Now, in Agile projects, this needs to be thought about before the iterations. If you're doing 2-week-long iterations, and you discover you need a new environment configured, that's going to be a problem, right? So do this during release planning. Also, tools. You want to think about tools in advance, not at the beginning of each iteration. Now, one of the trickiest parts of estimation is figuring out how long things are going to take. How long is it going to take us to run the tests? Okay? And the reason this is tricky is because it's actually a two-part question. The first part is, if all of the tests were to pass, how long would it take to get through them? Now, that's the minimum amount of time. But the second part of the question is, how long is it going to take to fix all the bugs? So, for the first part, in order to understand how long it's going to take to run your tests, you need to think about what the process looks like. What is the process by which you run the test? So here's an example. This would be a sequential lifecycle project. 6 weeks of test execution, broken down into 6 testing cycles, including a final cycle at the end. Okay? And each cycle is defined in such a way that there's confirmation testing of the bug fixes at the beginning, and then the scheduled automated and manual tests are run, and then there is a period of exploratory testing at the end. Okay? Now, if you're doing Agile, of course this would look different, right? But the same kind of things need to be kept in mind. When are you going to do your confirmation testing? When are you going to run your automated tests? When do you run your manual tests? For the non-scripted, exploratory, and other kinds of reactive tests, when are you going to run those? Okay? How frequently do you get your test releases? Every day? Every hour? Anytime anybody feels like giving you one? Have a defined process, right? If you don't have a defined process, you've got no way of estimating how long it's going to take, do you? If you're just purely reacting to events, who knows how long it will take to get through all your tests? In fact, I'd be willing to bet that you won't get through all your tests. right? So understand your process. Draw a picture like this. Now, in Agile, of course, again, it looks different, but you still have to think about how your testing activities are going to fit into the overall cycle that's going on. And you need to figure out how to coordinate those with the other testing activities that are happening, such as unit testing, continuous integration, acceptance testing, and so forth. Right? So, in a sequential lifecycle model, you have the luxury of operating more or less independently during the test execution period. In an agile lifecycle, you have to coordinate your test process with everybody else in the team. Right? Okay, how many bugs are you going to find and how long will it take to fix them? So, the best practice for dealing with this is to have historical data and use that historical data to build what's referred to as a defect removal model. So, an example of a defect removal model, a spreadsheet looks like this. Okay? So we've used historical data to be able to determine how many bugs we're going to find, and then how long it's going to take to find them, and then how long it will take to get them fixed. So this might be some final stabilization period at the end of an Agile project. It might be the system integration test during a sequential lifecycle project. But look at metrics. Now you might say, how in the world am I going to figure out how many bugs I'm going to find? Well, this is based on sizing. Okay? So if you're in an Agile type of world, then what you want to use for sizing are your story points. And how many bugs are you typically going to find per story point? Look at that in terms of historical data. If you're in a sequential type of project, what you'll want to use here is something like the number of developer days on the project, the size of the project. There are other techniques like using the thousands of source lines of code or function points, but for most of our clients that do this, the technique that they're using is person hours. Okay? Now, important thing to keep in mind here is that, let's see, do I have a pointer? Is there a pointer on this thing? See, yep, sure enough. So, this part is kind of under your control, the finding bugs, though it can be interrupted by blockages along the way. This part, the fixing of bugs, is not under your control, right? This is the development part of the process. So when you're estimating, make sure that you think about, what can I control, what can't I control? The things that you can't control are test-related project risks that need to be identified and managed, okay? Now this spreadsheet, by the way, if you're looking at it and going, how does this work? If you go to our website, on the basic library page on the website, you can download this and take a look at it. It's actually surprisingly simple how these things work. Okay, so I want to leave some time for questions here, so I'll wrap this up and then open it up for questions. I think it's about that time, right? Yeah. So estimation is very difficult to do well. Many organizations do this poorly. Hopefully I've given you some ideas on how to address this. As I said, there's more information out on our website. There is templates and checklists, and also a recorded version of this same presentation given as a webinar. It lasts about an hour and a half. So if you want to hear a more extended explanation of the material that I've gone through here this morning, you can go and listen to that. That is in the digital library. Just find the test estimation webinar. So I think this is very important because testing, whether we're talking about agile life cycles or sequential life cycles, is something that happens at the end of the process Without a good estimate, testing is necessarily going to be crunched. And so testing will be insufficient, and thus the quality of the software released will be less than it could otherwise be. So as a test manager in a sequential lifecycle project, or as a tester in an agile project, it's important that you master these estimation techniques. Okay? Know how to do good estimation. And measure yourself. Are you actually getting the right results? You know, as I said, if you plan on getting 10 things done in a day and being home by 6 o'clock, and you only get 8 things done in a day and you're not home until 10 o'clock, you didn't estimate well. So you should apply the same kind of approach to looking at your test estimates. Did you actually get done what you expected to get done? If not, why? And what can you learn? Now, that said, it is possible to do this well. If you practice, there is no magic to this. As I said, a lot of these test estimation techniques go way, way back in project management. So study the best practices, study the known techniques, apply them to your test estimation, and you can do this right. Okay, I think we're time for questions, yes? Yeah? Okay, so.
Вопросы есть? У кого-то вопросы какие-то?
We have a woman in a turquoise sweater back there, hand up in the air, she's waving her hand very vigorously. Someone want to take her a microphone, see?
Вот с этим сложно будет. Неопытный человек сможет перевести.
Keep waving, it's coming.
Hi, I'm Alexandra, and our team have a question for you, predefined question. Are your development team also perform estimation?
Should the development team also be? Oh, yes. Yes.
And do you have some process for this? In agile teams, Scrum Poker, for example, is for all team, but
right.
In not agile models, we have no process for development.
Well, the development manager should be creating a test estimate at the beginning of the project in parallel with the test manager. And ideally, they're working together, collaborating on their estimates, because your estimate for the testing in a sequential project is going to be very much dependent on the development manager's estimate for the development. You need to understand the size of what's being built. So for the development manager, what he or she needs is a way of sizing the development effort in terms of either function points or thousands of source lines of code or something along those lines. That will provide some meaningful metrics to do the sizing. The development manager should also be using the Defect Oracle technique that I mentioned, talking to the developers who are going to be developing the code. Now, in order to do that, the development manager will also need a work breakdown structure, because they're going to need to figure out what the tasks are, which is going to involve having a reasonably well-defined design of the system, right? Because if you don't know what you're building, it's not possible to say how long it's going to take to build it. It's like if I came to you and said, build me a boat, and you said, well, rowboat, sailboat, yacht, and I said, I don't know, I'll figure that out later, just get started. There's no way that you're going to be able to estimate that, right? So the development manager needs to know, this is what I'm actually supposed to build, for them to produce a reasonably good estimate. And then you can work collaboratively as a test manager to estimate the testing associated with that. But of course, it's important to keep in mind that if the development manager doesn't know what is to be built, because the customer or user basically came and said, build me a boat, and I'll tell you what kind of boat later, the development manager's estimate is nonsense, and your estimate is derived nonsense. You see what I mean? Because no matter how good a job you do on it, you're dependent on his or her estimate to be accurate, and if it's not, then yours is not.
Thank you. Yes, I understand that it's important, but we have a problem maybe with the humor factor. because our test estimations have a lot of breakdowns, and they are maybe 80% correct in the end of project. But developers, they take a raw estimate, so it will take 2 days, some tasks, and they are not correct in the end. They have no estimation checklist, estimation process, and that's why testing team have a problems.
Yeah, I mean, testing, this is an example of a general problem in testing, which is that testing is downstream from everything else in the project, just about. Which means that any amount of nonsense, bad planning, bad estimation, incompetence, anything that chaos that's going on upstream, that will leak into your process, right? So you, as a test manager, can only do a marginally better job of managing than the worst manager in the project, right? Because the worst manager in the project is going to create noise, chaos, that is going to come in and sabotage your attempts to manage your testing. So that's something to remember as a test manager. Is that, you know, if there is somebody managing development or configuration management, release engineering, any of those kinds of things, and they are screwing up, that will impact you. And there's, you know, all you can do is identify the risks related to that and take steps to try to manage those risks.
Thank you. We'll give the noise for our developer.
Okay. Good luck.
Еще вопрос, да?
We have a lady here in a black jacket and a gentleman here in a blue jacket.
Hi, my name is Jan.
Morning.
My question is about theory of constraint. Do you have this practice in your work or not?
I have to be honest, I haven't read that book. I've heard of it and heard good things about it, but I've not read it. So I mean, my understanding is it's something kind of Kanban-ish, but that's, you know, very weak understanding.
What about risk in your projects? Could you describe some very frequency and the most important of them?
Risk?
Yes.
You mean risks that would affect your ability to test?
Risk in development process.
Risks in the development process.
Yeah.
Well, so the example that I gave of the missing cable is a very common type of risk. That's the test environment isn't set up right risk. Okay, so you definitely want to think about that one. There's the developers give you software that can't be tested risk. Right? That's also very common. The worst example of that is software that won't even install. Now, fortunately, most of our clients that are following agile methodologies, because they have continuous integration, that usually doesn't happen. But software that's not of sufficient quality to be testable still can happen even in a continuous integration framework. So that's a risk that needs to be addressed. The classic risks, like a key player in the project quits or gets sick, gets injured, goes on long-term leave, you know, you have to be prepared to deal with those kinds of risks as well. Tools, vendor-related issues. You know, if you're using third-party testing tools, you know, you have to be ready for potential problems with that. Even open source tools can also be an issue. So there is on the RBCS website a example of a test plan that you can download if you want to take a look at it. And it includes a section that talks about test-related project risks that need to be managed. So it might be a useful set of examples for you.
Thank you.
Okay. Пожалуйста.
Осталось 2 минуты, давайте еще один вопрос. Когда подойду, давайте.
I believe the lady here with a black jacket.
Hello, my name is Kate, thank you. And my question is, when you start to estimate your testing, at first time you estimations is not accurate, it's a lot of errors.
Yes.
and how time needs to make your estimations more correct. One iteration, 10 years, how, how many time I need to make my estimations to pretty good.
So part of that is applying good techniques to start with, right? So, you know, there's this Japanese concept of Kaizen, continuous improvement, which basically says, you know, no matter where you start, as long as you focus on continuously improving, basically listening to feedback from how well you did, you will eventually get really good. But as you pointed out, that could take 10 years. So it's better to start by mastering the best practices of estimation first, so that even the first time you do it, you do the best job you possibly can, understanding that that will not be a particularly good job the first time, right? But you do it, and then you reflect on how well you did it, right? The difference between what you thought you could get done and what you actually got done. Recognize the differences. Why did you not get done what you thought you could get done? Figure out the contributors to those problems, solve them, repeat, right? That's the Kaizen piece. Now, you should be gathering metrics on this as well. So if you're in Agile, you know, look at things like velocity, look at things like how many bugs found per user story, how many test cases created per user story. Start to gather some metrics so that you can look at, from a metrics point of view, one iteration to the next, what is our testing velocity? Right? Testing velocity in terms of bugs found, bugs fixed, test cases created, test cases run. Start to accumulate some reliable historical data that you can use, just like the development teams use velocity, right? And then you can start to do that same kind of thing. Now, that's all predicated on a stable process. Do you see what I mean? If your process is constantly changing, then you will not be able to estimate it, right? Because it's back to that, one day you're building a rowboat, and then 2 weeks later you're building a yacht. You know, you can't estimate reliably in that kind of chaos. So that's something to make sure that you understand is, when you fail to achieve your estimates, ask yourself, was that because of internal factors that affected my ability to get done, right? Those are things under your control you can solve. Or was that because of external factors? And if it was due to external factors, then you say, are those predictable and repeatable factors that I can manage? Or were they just totally unpredictable changes that came along? And in that case, you don't have an estimation problem, right? If what's causing you to miss your estimates is unpredictable external events that are not under your control, but could be controlled by more senior management, then what you need to do is gather some data on the costs being inflicted on your projects by this chaos, and then go and try to motivate management to control that chaos. Because otherwise you're just like a ping pong ball in the wind, just bouncing around, and you know, your ability to control that will be very minimal.
Thank you.
You're welcome.
Да, время закончилось.
Thank you.
По этим вопросам там еще будет. Мы перейдем к Рексу и отдельные задачи. Все? Перерыв?